Hello everyone, welcome to In 5 Minutes. In this video clip, we will discuss one numerical on power calculations in AM system. The question says when the modulation percentage is 75, an AM transmitter produces 1 kilowatt of power. How much of this is carrier power? That's the first question. The second part is what would be the percentage power saving if the carrier and one of its sideband were suppressed before transmission? That's the question. So let us solve this particular question. The first part, they have given AM transmitter producing the power. That means without any doubt it is the total power. They had given us the total power and they are saying modulation percentage is 75. That means small m, which is modulation index, will be nothing but 75 by 100, and that will be equal to 0.75. So we know one relationship which is between total power and the carrier power, which says that the total power is equal to carrier power into 1 plus m square by 2. From this equation I can get the carrier power. The total power Pt divided by 1 plus m square by 2. The total power is 1k, so 1 into 10 is to 3, and this is divided by 1 plus m will be 0.75 square divided by 2. So on solving, we will get the carrier power equal to 780 watts. So out of 1 kilo, 780 watts will be the carrier power. So only the remaining power will be present in the sideband. So this is the first part of the question. Now let's solve the second part of the question, which says that how much power saving will take place if the carrier and one of its sideband were suppressed before transmission. So let us find out power saved first. Power saved will be equal to carrier power because carrier is not suppressed, plus it will also be one sideband power because one sideband is also suppressed. But if you remember the discussion on single sideband generation, you can never generate single sideband without first generating double sideband signal, and hence moment you generate double sideband signal, you have used power to generate two sidebands. Now even if I suppress one of the two sidebands using, let's say, filter method, it will not give me any advantage in terms of power saving. So even when the question mentions that one sideband is also suppressed, that sideband suppression will not help us in power saving. The power saving will be only due to the suppression of carrier. So please remember that generation of suppressed carrier signal is possible without generating carrier at the output side, which can be done using balanced modulator, ring modulator, etc. But generation of single sideband is never possible in first go. We have to first generate two sidebands and then generate one sideband by suppressing the other one. So power saving is only due to the suppression of carrier. So power saved is PC, and we already know carrier power, which is 780 watt. So what will be percentage power saving? Percentage power saving will be nothing but it will be equal to power saved divided by total power transmitted into 100. So power saved is 780 divided by total power transmitted was 1k, that means 1 into 10 is to 3 into 100, and this will give me 78. So percentage power saving is equal to 78. 78% of power will be saved if I suppress the carrier signal, and no further power saving will be possible because suppression of one of the two sidebands will not result in any power saving. So that's the answer to the second part of the question. You can see that the power saving is very huge, and this is what generally happens when we suppress the carrier. We save a lot of power, and hence suppressed carrier signal, whether it is double sideband or single sideband, has very high power efficiency compared to double sideband full carrier signal.